Here is the homework for Algebra 2. It's a review worksheet 5.4 to 5.6. We are going to review long division, synthetic division, and finding the real and imaginary roots. So for question number 1, you have to use long division because the degree is 1, but the leading coefficient is 3. So you're going to put 3x minus 2 outside, that's your divisor, 27x cubed plus 9x squared minus 3x minus 9. Here's the process for long division. You want to get rid of 27x cubed. So you need 9x squared. Because 9x squared times 3x is 27x cubed. And then 9 times negative 2 is 18x squared. Now what you're going to do with these two is subtract them. These cancel, but this 9 minus a negative, that's going to be 27x squared because that's going to be a positive 18. Okay, now you're going to bring down negative 3x. 3x times what is 27x squared? So we need a 9x. 9x times 3x is 27x squared, and then minus 18x. We're going to subtract these two. These cancel. You get negative 3 plus, that's going to be a plus 18. So you have 15x, bring down the minus 9, and we need a 5 here. 5 times 3x is 15x, and 5 times negative 2, negative 10. And when we subtract, these cancel, you get negative 9 plus 10, which is 1. So we have a remainder of 1 over 3x minus 2. Number 2. This one we're going to do 2x minus 3 as your divisor, and 4x to the 4th minus 8x cubed plus 11x squared plus 18x minus 45. So we need to first get rid of 4x to the 4th. So we need a 2x cubed. 2x cubed times both of these is 4x to the 4th minus 6x cubed. When we subtract these, this is going to become a positive, so you have negative 2x cubed plus 11x squared. So 2x times negative x squared, this times this is negative 2x cubed, and this times this is positive 3x squared. So when you subtract these, you end up with 8x squared, and then bring down 18x, and we get a 4x here. 4x times this is 8x squared minus 12x. When we subtract these, you end up getting 18 minus a negative 12 is 30x. Bring down minus 45. And 2 times 15 is 30x. And 15 times 3 is 45, so it's negative 45. These are both going to subtract and give you a 0 remainder, so that is your answer. Number 3 and 4 are asking you, if this problem said divide x plus 2, we would take negative 2 and evaluate this with synthetic division. So if we put a negative 2 here, you get negative 3, 5, a 0 for x squared, negative 1 and 7. Bring down the negative 3. Multiply, you get 6. Add, negative 22. Add those two, you get 44. Add, you get 43. Multiply, you get negative 680. 43 times 2 is 86, so negative 86. And you get negative 79 for an answer. So this would be your remainder. Now if you evaluate, if you put a negative 2 in here, so you do negative 3 times negative 2 to the 4th power plus 5 times negative 2 cubed minus negative 2 plus 7. Well, 2 times 2 is 8, times 2 is 16, 24, so 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 16, it's going to be positive, times negative 3 is negative 48. Plus, negative 2 times negative 2 times negative 2 is negative 8. Negative 8 times 5 is negative 40. So these two give you negative 88. These are going to cancel to give you 2 plus 7 is 9, and your answer is negative 79. Number 4, you're going to plug a 5 in and do synthetic division. 5, you get 4, then there's no x squared, negative 12, negative 2. Bring down the 4. 5 times 4 is 20, add. You get 5 times 20 is 100, add, you get 78, nope, 88. 88, and multiply 88 times 5, you get 40, 440. Let's see if that's right. 88 is 440 minus 2 is 338. So we should get 338 for a remainder if we plug 5 in here. So 4 times 5 to the 3rd minus 12 times 5 and then minus 2. So if we use our calculator, we have 4 and then 5 to the 3rd power and then minus 12 times 5, and then we have minus 2, and you get 550. What did I do wrong? Bring down the 4. X squared, negative, negative. 4, 20, 100. 100 minus 12 is 88. 88 times 5 is 440. 440 minus 2. So this is, I'm sorry, this is 438. 438 for an answer. 438, that's my error. Now this, you're going to plug a 5 in. 5 cubed. 5 times 5 times 5 is 125. 125 times 4 is 500. Minus, this is going to be 60. So minus 62. 500 minus 62 is 438. So it did work. Must have typed something wrong in the calculator. So it is correct. These give you the same answer. Number 5, it says use synthetic division to determine if this binomial is a factor of the given polynomial. So let's do that first. We're going to put negative 4 in here. We have a 1. We have 0x squared. Then we have negative 13. And then we have 12. So bring down the 1, multiply, 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 and yes, it is a factor. And then it says, if so, completely factor this polynomial. So this is going to be x squared minus 4x plus 3. So you would factor this to be x minus 3, x minus 1, and bring down your x plus 4. That is, since that worked. So this is factored completely. Number 6, we're going to try 2. We're going to plug a 2 in here. We have a 1, a negative 6, negative 9, and 14. Bring down the 1, multiply, add, multiply, add, and you're going to get negative 34 here. So it does not work. You get negative 20. So since the remainder was negative 20, it is not a factor. Number 7, we've got a list of things to do. What I want you to do is first tell me how many possible zeros are there. There's at most 4 possible zeros. What are the possible real zeros? You're going to take factors of P over factors of Q. So we have plus or minus 1. What numbers go into 15? Plus or minus 1, 3, 5, and 15 over factors of 4, which are plus or minus 1, 2, and 4. Those are your possibles. Now the end behavior, because this is a degree of 4 and the leading coefficient's a negative, both are going to go down. Left and right are going to go down. The maximum number of turns, you're going to go 1 degree less than this, so it's 3, but the possible would be 1 or 3. Next, the number of possible zeros are 4. To find the complex zeros, you'd have to actually do the problem. We're not going to do number 1. So what are your possible zeros? You're going to take combinations of P over Q. So 1 and 2 and 3 and 6 are P's. Over Q's are 1 and 2. So you'll make up combinations of these numbers. The end behavior, because this is a degree of 4 and a leading coefficient that's positive, both the left and the right will go up. Both go up. The maximum number of turns, again, is 1 less than that, but there could be 1 or 3. Number 9. For this one, you're going to use the P over Q test, and I tried 1. 1 doesn't work, and then I tried 2. 2 works. So if you put a 2 in here, 1, negative 4, 0, and 8. Bring down the 1, multiply, add, multiply, add, multiply, and you get your first 0. So 2 is one of the zeros. To find the other ones, this is going to be x squared minus 2x minus 4. You will factor this to x minus 4, x plus 2. So the other 2 zeros are 4 and negative 2. So we have 2. 2 is one of the zeros, and 4 and negative 2 are the other ones. Number 9. This one is a 4th degree. We did this on the last test. It's a 4th degree problem that is factorable. When you see it go from 4 to 2 to your constant, see if you can break this up. This is going to be x squared times x squared. And what 2 numbers multiply to give you positive 12 but add to be negative 7? You can only do it when it goes from 4 to 2 like that. So negative 3 and negative 4 multiply to give you 12 and add to be negative 7. So what you would do now is set each of these equal to 0. So you have x squared minus 3 equals 0, add 3, square root both sides, and you get x is equal to plus or minus root 3. Then for this one, x squared minus 4 equals 0, add 4, and square root both sides, you get plus or minus 2. These are all real zeros, but these are irrational, and these are rational zeros. Number 11, what you're going to do here is see that you're asked to find all the zeros, real and imaginary. So you're going to pull an x out here because it's the GCF. So you have 6x squared plus x minus 1. Now what you're going to do is see if you can factor this, and it is factorable. 3x times 2x is 6x squared, and if you put a 1 here and a negative 1 here, when you FOIL this out, you'll get a positive 1 in your middle term. So what are your zeros? 0, this is going to be 1/3, and this is going to be negative 1/2. These are all real zeros. Number 12. Your possible zeros, you're going to do possible P over Q values, and I'm just going to go quickly on this. You're going to say that negative 4 does work. You end up with 2, 1, negative 22. You have to go through the process and try 1, 2, like that. Bring down the 2, you get negative 8, negative 7, negative 20, positive 28, 6, negative 24, and you get your 0. So negative 4 is a 0. So in other words, this would look like this. X plus 4, then 2x squared minus 7x plus 6. Now, this is factorable. We can pull a 2x out, and if you put a negative 2 here, that's going to give you negative 4, and negative 3, you're going to get negative 7 for a middle term. So what are your zeros? It's going to be negative 4, and 3 halves, and 2. Those are your zeros. Number 13. For this one, you're going to do P over Q, and I'm going to tell you negative 1 works. Negative 1 will work. 1, negative 3, negative 1, negative 9, and negative 12. So bring down the 1, you get negative 1, negative 4, 4, 3, negative 3, negative 12, positive 12, and 0. So you have x plus 1 with this 0, and then you have x cubed minus 4x squared plus 3x minus 12. Now with this, you're going to factor again, and 4 works. 1, negative 4, 3, and negative 12. Bring down the 1, you get 4, 0, 0, 3, 12, 0. So you have now, bringing this down, you have x plus 1, and then x minus 4, and then right here, you're going to go 1 degree less than this problem, so x squared plus 3. Now how do you find these two zeros? You're going to set this equal to 0. You're going to bring over the 3. It becomes a negative 3, square root both sides, and you get plus or minus root 3i. These are imaginary, but negative 1 and 4 are real. These are real and 2 are imaginary. It says find all. Number 14. This one, I would factor out a negative 4x, and you're left with x squared minus 25. And this is the difference of 2 perfect squares. So your zeros are 0, 5, and negative 5. So this one you can just pull out negative 4x and find your zeros that way. 2 more. Number 15. If I give you negative 3 and 1 are your zeros, those are real, you would write in factored form x plus 3 times x minus 1. And if square root of 5 is a 0, you'd have x minus root 5, and because they come in pairs, x plus root 5. So if you were to factor these two, you get x squared plus 2x minus 3. And for this one, if you were to factor it, you get x squared minus 5. And what you'd want to do here is now FOIL this and get your polynomial in standard form. The last problem, we have a cubic function. You have x plus 5. And then you have, if 4i is a 0, you have x minus 4i. And then you have x plus 4i. Well, if you factor this, you get x squared. This is going to give you x squared, and then it's going to give you plus 16. And you're going to want to FOIL this, x plus 5, into that. And if you want, it's going to be a cubic. If you want it to fall and rise, your leading coefficient would be a positive. So FOIL this, you get x cubed. This times this is x cubed, plus 16x, plus 5x squared, and then plus 80. 5 times 6 is 80. So in standard form, we're going to have x cubed plus 5x squared plus 16x plus 80. And with a positive leading coefficient, it's a cubic function. It's rising, it's falling on the left and rising on the right.